Okay, so we've been solving oblique triangles. And in the triangle on the left, we have the situation where we have side-side angle. Okay, I have two sides, one angle, two sides, and one of the sides is opposite the angle. So I'm able to use the law of sines. Okay, that's the only situation with law of sines where there are two sides and one angle. Okay, we do have another situation where we have two sides and one angle, but now the angle is not opposite one of the sides. So on the right here, we have side, angle, side, where the angle is between the two sides. So therefore, I cannot use the law of sines because I have an angle, but I don't know the side opposite. I have two sides, but I don't know either angle opposite those. Okay, so what do we do if we can't use the law of cosines? Well, you're in luck. We have something we can use, and that is the law of cosines. So basically, here's what I say. If you can't use the law of sines, then you use the law of cosines. So law of sines, remember, requires that we have an angle and a side opposite. So it's angle, angle, side, two angles, side opposite one of those, angle, side angle, two angles, the included angle, or side, side angle. The one, if we spell it backwards, we get in trouble. Okay, so in all of these, notice we have an angle, or we might have two. So law of sines works in that situation where we said we have two sides and the included angle, or how about a situation where we don't have an angle at all? So in a situation where we have side, side, side. Okay, I'm not going to derive this for you because it's fairly tedious. So if you're interested in seeing how they derive the law of cosines, it's on page 760 in the book. Okay, so once again, here's what it says. If we have our triangle that's set up with capital letters are the angles, lowercase letters are the lengths of the sides opposite, okay, then here's the relationship. We have three equations or formulas, if you want to call them that, but hopefully you recognize there's a pattern. So out here on the left side, each equation is either solved for a, b, or c squared. Okay, so if you're using the law of cosines to find a side, you're going to choose which of these are you trying to find. Are you trying to find a, b, or c? Okay, that means if you're going to use it to find a side, then you have to know everything else. If you're trying to find side A, you must know side B and side C, and A, which happens to be the angle opposite that side. Okay, so you're going to use all three sides. You could be using all three sides, or you could be using two of the sides and finding the third. Okay, the other thing we can do is use law of cosines to find an angle. If I have three sides, I have to find an angle. So you'll choose which one of the angles you're trying to find, A, B, or C, and choose that formula. But hopefully you can see a pattern. If I have a squared here, then I have to have b squared plus c squared minus 2bc. So you're using the same variables here that you multiply by 2 as you did individually when you square and add them together. Okay, these are the steps that you should follow when you're using law of cosines to do your initial step here of the solving. So if you have side, angle, side, you're going to use law of cosines to find the third side. You're going to find a side. If you have three sides, you're going to use law of cosines to find an angle. Okay, so we're going to look at both of those situations. All right, so let's go back to our original triangle that we looked at, and we can see then we have side, angle, side, two sides in the included angle. So I cannot use law of cosines, law of sines. So what I want to do is I'm going to find the side opposite the given angle. So I'm going to find that third side, which is B. Okay, so if I want B, then I choose the formula that has the B squared by itself out to on the left-hand side. That means then I have to take the other two sides, A squared and C squared, or take the other two sides, square them, add them up, minus 2 times those two sides, AC, times the cosine of angle B. Okay, so notice on the right, you never use lowercase b, you only use lowercase a and c. And then it's just a matter of substituting in and doing a little plug and chug, as I like to call it. Okay, so we're going to find b squared. So I'm going to substitute in my values. I can see then that a is 7 and little c is 5. Doesn't really matter because you can switch them around. It's going to be the same situation, but we should plug them in the appropriate place. Okay, so little a is 7, so 7 squared. Little c is 5, 5 squared, minus 2 times 7 times 5 times the cosine of angle B, which is 115 degrees. Okay, so this is probably the nicest of the two situations because all we really have to do is put that in the calculator. Make sure that you are in degree mode when you use your calculator, and you just plug that in. And I'm going to write down what I get for b squared. I don't care if you write this step because I certainly don't want you to use a rounded value unless you just want to write something on your paper. But you can go directly to the final step. Okay, so it should come out with 103.58327, and I say ... because it keeps going, and I do not want you to round that. Okay, so leave it on your calculator. All right, that's b squared, but I want b. So what would we do with that number? We would take the square root. So if you wanted to put the square root in your calculator to begin with, that would be totally fine. Try to use exact, try not to round to the very end. And then we're going to approximate, let's round that to 10.18. Okay, so that side is approximately 10.18. Now, if you want to keep a little running tally, you can. I don't have a lot of room here, so I'm not going to, but all right. So then we've got now we have all three sides. Now we have to work on an angle. And here's where it really is important to follow this guideline because bad things can happen if you don't. All right. So the next step is you're going to find one of these two angles, A or C, and you want to find the smaller of the two. The reason being, and I've seen this happen, students do it on a test, or I've seen it happen different homework problems. So find the smaller of those two angles. So which one is smaller, A or C? Well, the angle that's opposite the shorter of the two sides. So C is the shorter, so that's going to be the smaller of the two angles. So I am going to find C next, okay? Now, angle C. Now, here's the deal. You can use law of sines now, totally fine. You do not have to use law of cosines if you don't want to. Using law of cosines to find an angle is pretty tedious. You haven't seen it yet, but I think once you see it, you'll recognize that law of sines is better. So find angle C, and then you can just use law of sines. Okay, which we'll just set that up real quick. We've done that, so that's a review. So if I'm finding angle C, then that means I'm going to put the sine of C on top, opposite side, the side opposite angle C, which is 5. I need another angle and side opposite pair, which I only have one. So I have the sine of 115 degrees over, and here I can't get away with not having to use a rounded value. So we're going to have to use that rounded value there. Okay, so what are we going to do? We're going to solve for sine of C. So I want sine of C all by itself, and then I can find what C is using my calculator. So I'm going to then cross multiply and divide, or multiply both sides by 5. Maybe I should put that in parentheses. So I could write it out here. That's why I put it in parentheses. Or if you separate it like this, you won't think it's attached to the 115 degrees, I would say. You could always put the 5 in front of the sine of 115. Okay, so that is going to give me the sine of angle C. Now, this, once again, you don't have to write this on your paper, but I want to have it so you can see it. When you put that expression there in the calculator, you should get this. Notice I'm putting dot, 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 so I didn't round. Okay, so I'm saying this value is the sine of some angle C. So how do I find C? Then I do the inverse sine of that value. Okay, so use that exact value on your calculator. What we will do, we could do is just put the inverse sign in front of up here eventually. Okay, once you've done this a few times. So that means then, once again, you're in degree mode. So it comes out to be, let's round. Sometimes we round angles to a whole number, sometimes a decimal. I'm going to go ahead and do a decimal. 26.4 degrees. Okay. And then what do I need now? I need the third angle, which is angle A. So if this one is 26.4, then I know they add up to be 180, the three angles. So A is going to be 180 minus 115 minus 26.4, which is 38.6, I believe. Okay, so we now have the measures of all three angles and all three sides. Okay, now let's look at the other situation. What if I'm given the measures of three sides, which means I'm going to have to use law of sines to find an angle. Okay, now one thing we have to check first of all is the three values that they give us for the sides. Will it actually make a triangle? Okay, so there's this triangle side length restriction. Basically, it's saying that if you look at the two shortest sides, for example, in A, if I look at the two shorter ones, A and C, if I add those together, I get 14. Okay, so it says the sum of any two sides always has to be longer than or greater than the third side. The third side is 16. Is the sum of those two greater than 16? No. Okay, so basically those two sides are not long enough to meet. So if you're a visual person, this is the way I look at it. If this is my side that's 16, right? And then I have 9 and 5. So this is not drawn to scale, of course. So if this is my side that's 9 and this is my side that's 5, then they're not going to be long enough to come together. So you could kind of think of it as if I put this side down flat here, and I put this side down flat, then what we're saying is they're Well, if there was no angle at all, those would not even, they don't even touch. Okay, so this will, there's no triangle here, meaning there is no solution. I can't find a triangle with those three sides because it won't meet. Okay, so you really only have to check the two shorter sides. Here I think I'm good. 3 plus 7 is 10, and 10 is greater than 8. So there is a triangle, so we could go ahead and solve the triangle, which means I would need to then find the three angles. Okay, so let's use that one and go ahead and solve it. Okay, so I'm just going to draw a quick sketch over here. Once again, not to scale. Okay, so if this is A, B, C, the side opposite angle A is 3, the side opposite angle B is 7, and opposite angle C is 8. Whoops. Okay, now which side do we find first? This one isn't a hard and fast rule, but it's a nice idea. If you find the largest angle first, then you know if you have an obtuse triangle or not. Because the largest angle, there can only be one obtuse angle in the triangle. Okay, so that way we get it out of the way and we know what to expect. And you'll be able to tell that by the value that you get for cosine. So we'll talk about that when we get there. Okay, so if I'm going to find the largest angle, that happens to be C because it's opposite the longest side. So I'm going to find angle C. Now, this is where it's a little tedious to use the law of cosines to find an angle. All right, so if I'm finding angle C, then I choose the formula that has little c all by itself. So this is the one I'm going to use. Little c squared is equal to then a squared plus b squared minus 2ab times the cosine of c. Here's the idea. These two are always opposite side and the angle opposite. So if I'm not finding side c, then I'm finding angle c. So what I need to do is isolate the cosine of c, and then I can find out what angle c is. Okay, so substitute in. So I have 8 squared is equal to 3 squared plus 7 squared minus 2 times 3 times 7 times the cosine of angle C. Okay, now here's where the algebra is that's a little tedious. Okay, remember I want to isolate this. Okay, so I would simplify it first. Okay, I think you'll see it better. All right, so this is 64, this is 9, 49 minus 2 times 3 is 6 times 7 is 42. Okay, so now let's think about this for a second. This is like my variable, okay? So that means this is my variable term. That was, if the cosine C was an x, you would isolate this term. Okay, so we have a little bit more work to do. 9 plus 49 is 58. Okay, so I want to isolate this term. So I'm going to subtract 58, which gives me 6, I believe, equals negative 42 times the cosine of C. Okay, now I want to isolate this, so I have to get rid of the 42, the negative 42 by dividing. So I have the cosine of angle C is equal to, now you can reduce it or you can leave it just like this, it doesn't matter. All right, so I'm saying there's an angle whose cosine is that. Now, here's how I know if it's obtuse or not. Okay, so think about, if you're putting this in your calculator, you're saying, okay, angle C is the inverse cosine of negative 6 over 42. Okay? This is negative. If you think about inverse cosine, it's an angle in quadrant 1 or quadrant 2. Well, cosine is negative in quadrant 2, so that means it has to be an obtuse angle, meaning between 90 and 180. Okay, so use your calculator for that, and you would come out up with 98.21 whatever that is, rounds to about 98.2 degrees. Okay, so that is a little tedious finding that angle. All right, you can then finish solving the triangle. This is angle C. Whoops, jumpy. 98.2. Okay, so then it doesn't matter which one you find next. Find either of the remaining two angles using the law of sines. Okay, so I'm thinking makes no difference. So let's find angle A. Okay, so we'll set that up. So that would be the sine of angle A over the side opposite angle A, which I believe is 3, is equal to the sine of the angle that we know, and the only angle we know is our 98.2. So once again, I can't get away from using a rounded value. The side opposite angle C, which is that, is 8. Okay, so we want to solve this for angle A. And here's where you could jump to the next step if you want, because you're going to find the inverse sine of whatever that is. So you would be multiplying both sides by 3, right? And then you would be saying that's this right here. So whatever that comes out to be is going to go in here. So you can jump right to the inverse sine step, would be fine with me. So it'd be the sine of 98.2 over 8 times 3. Okay, actually it might be better to put the 3 out front. So 3 times the sine of 98.2 over 8 would probably be better. Okay, so do the inverse sine of that, which comes out to be, I think 21.8. All right, so then we could find angle B, which should come out to be approximately 60. Okay, and there you have it. One last thing. There, you can, if you would prefer, instead of going through these steps here to isolate the angle that you're trying to find or cosine of the angle you're trying to find, you can always rearrange the original formula if you'd like. So for example, if I have a squared is b squared plus c squared minus 2bc times the cosine of a. If you do some rearranging, you can rearrange it so that you have the cosine of a isolated. Okay, so because this is negative, we would be dividing by that. We don't like to have a negative in the denominator, so we're going to go to the opposite side to make it nice. So we could move this to this side, move the a squared to this side. So we would have b squared plus c squared minus a squared. When I move this over, I add, so I have divided by 2bc times the cosine of, oops, I'm sorry, that's not, whoops, that's what I was getting by itself, divided by 2bc. So this is the formula for cosine of A, but you see that you could rearrange the other two in a similar fashion. Totally fine if you use that. And there you go. We have something to use to solve any kind of a triangle.